Hello, today in this lesson, CAMs, let us discuss about roller follower, moving with simple harmonic motion, and uniform acceleration and retardation. In this lesson, the objectives are, on completion of this lesson, you will be able to draw the displacement diagrams and profile of the cam when the roller follower moving with simple harmonic motion, and the profile of the cam when the roller follower moves with the uniform acceleration and retardation. And these things we are going to discuss in this lesson, and you would be able to draw displacement diagrams as well as the profiles of the cam for a roller follower moving with a simple harmonic motion and uniform acceleration and retardation. So first of all, the cam profiles for a roller follower with a simple harmonic motion. As we are aware that how to draw the displacement diagrams for simple harmonic motion, and also we have seen in the previous lessons the follower moving with uniform acceleration velocity for a knife edge follower, and for knife edge follower simple harmonic motion and uniform acceleration retardation also have completed. And also in the previous lesson we have completed also a roller follower moving with uniform velocity. And now in this lesson we are discussing about the cam profiles for a roller follower with the simple harmonic motion as well as uniform acceleration and retardation. Now here in this displacement diagrams and cam profiles, the cam usually rotates at uniform speed, as we are aware that, so that the angular displacement takes place in equal intervals of time. The follower is required to start from rest at the beginning of each stroke and to come rest again at the end of each stroke, so its velocity must be variable. And also dwell definition also we have completed in the previous lesson only. That is stationary period. The follower is nothing but the period of dwell or angle of dwell, we can say. And here is the simple harmonic motion displacement diagram, as we are already aware that, and how to draw this diagram also we have discussed it so far previously for knife edge follower. And now for displacement diagram for simple harmonic motion for any follower is same, no difference in case of displacement diagrams for any type of follower. So that here in this case, once again I will recall the how to draw the displacement diagram with the follower moving with simple harmonic motion. So here you can see, as we are aware that generally every cam will have four angles, cam angles. That is, one is the angle of ascent, or we can also call it as outstroke, and a dwell period, and then return stroke, and also second dwell period. Sometimes we may have dwell period in between the outstroke and return stroke, we may not have, but always in all the displacement diagrams and all the cams will have both outstroke and return stroke. So that's why in this diagram, most important aspect is the drawing of for displacement diagrams for both outstroke as well as return stroke. It is angle of ascent and angle of descent. And here also we are discussing about if the follower moving with simple harmonic motion as discussed earlier, let it be recalled. So let us see, he from A to B will be the outstroke or angle of ascent or angle of rise, and B to C will be the dwell period after the rise or after the outstroke or before the return stroke. So from C to D will be the return stroke or in stroke or also angle of fall or angle of descent also we can call, and D to E will be the dwell period. So here these are the 4 stages, and totally with all these 4 stages will constitute one revolution, complete in one revolution, that is 360 degrees of rotation of cam. So here in this case, that means from A to E, if you take, it is 360 degrees. And now to draw this displacement diagram, we should take proper scale as per our convenience. So some people may take different scale, some people may take any other scale, but I am here, I will prefer to take, depending on the angles, generally 30 degrees of cam rotation or angular displacement is equal to 10 mm as the scale. So that's why from A to E it is 360 degrees of cam rotation. Thereby if you take the scale for 30 degrees is equal to 1 centimeter or 10 mm, then A to E will become 120 mm or 12 centimeters. So after taking A to E is equal to either 120 mm or 12 centimeters as per our scale. Depending on the outstroke, this should be also be converted into millimeters or centimeters. And next is dwell period also should be converted, and C to D outstroke also similarly we have to convert. And divide this AB into any even number of equal parts, and similarly CD out return stroke also should be the same number of equal parts. And we have to project or we have to draw lines vertically from each point in the outstroke as well as the return stroke by and we have to complete the total rectangle, and we have to draw a semicircle with the half of the stroke length as the radius, and divide this semicircle into same number of parts as done on outstroke as well as return stroke. If you take this as 6 divisions and also this 6 divisions, you should make this semicircle also into 6 divisions. And next is, as we have already completed vertical lines from each point in the outstroke as well as return stroke, similarly draw horizontal lines from each point of semicircle. That is, say this is 1 and 2, 3, 4, 5, 6, 7 and 8, and from each point you draw vertical lines to meet the from each point of semicircle we have to draw horizontal lines to intersect the vertical lines of outstroke and return stroke. And say suppose the point 1 or division of one horizontal line is going to intersect the vertical line of 1, that is vertical line of outstroke 1 will intersect, that will intersecting point will become, intersecting point is the one point, say A, and similarly second point of semicircle and second point of vertical line intersect at one point, and similarly third point, and so on in the outstroke, similarly in return stroke also. If you take A, B, C, so on, capital A, small a, B, C, D, E, F, G, H, and so on, and similarly H dash, and up to here D. If you mark all the points, and if you draw a smooth curve starting from A, B1, C1, and then D, E, that will become the displacement diagram when the follower moving with simple harmonic motion. So this S will be the lift or stroke length. So the complete displacement diagram for simple harmonic motion of the follower is A, B1, C1, D, E, as shown in this figure, above figure. And here the procedure for displacement diagram, once again just recall this one. Draw a semicircle on the follower stroke as diameter and divide the semicircle into any convenient even number of equal parts. Divide the angular displacements of the cam during the outstroke and the return strokes of the follower into the same number of equal parts. And the points on the displacement diagram are obtained by projecting the points as shown in figure. Say, as I explained, the complete displacement curve is given by A, B1, C1, D, E. So this is the displacement diagram, and then let us see one problem in this aspect. So that is roller follower moving with simple harmonic motion. Now here the problem is draw the profile of a cam operating a roller reciprocating follower passing through the cam axis and with the following data. So minimum radius of the cam is 25 mm, that is in order to draw the base circle diameter, and the lift is equal to, that is S, vertical line, that is 30 mm, and roller diameter 15 mm, and this will help to draw the rollers on the cam profile and also to draw the prime circle by taking minimum radius of cam plus half of the roller diameter. That will give you the prime circle radius. And the cam lifts the follower for 120 degrees with the simple harmonic motion. That means outstroke is, that is lifting, angle of lift, or you can say angle of rise or angle of ascent is 120 degrees simple harmonic motion, followed by a dwell period of 30 degrees. Then the follower lowers down, it means falling or return stroke during 150 degrees of the cam rotation with the uniform acceleration followed by a dwell period. So here in this case there are two different things are there. Outstroke is simple harmonic motion, whereas the return stroke or angle of descent will be the different motion, that is uniform acceleration followed by the dwell period. So now for this, what will be the solution? Let us have this. First of all, let us see the data. Radius of the cam RC is equal to 25 mm, and the radius of the roller is equal to r, small r is equal to 7.5 mm, that is diameter is as 15 mm only. And then lift of the cam h is equal to 30 mm, and cam rotation for outstroke is 120 degrees. Cam rotation for dwell is 30 degrees, dwell 1, and cam rotation for return stroke is 150 degrees, and cam rotation for dwell 2 is 60 degrees. And now let us have the displacement diagram in this. Draw the horizontal line representing the 360 degrees to some scale, suitable scale, and on this line 0 to 6 is equal to, take 0 to 6, 120 degrees, that means 6 divisions, equal divisions for outstroke, and then 6 to 6 dash will become the 30 degrees for dwell period, and 6 dash to 14, that is 150 degrees for return stroke. Actually this should be 6 dash to 0 dash, that should be 150 degrees for return stroke, and the remaining will be the second dwell period. So here is the different problem, it is a different method also. Here we can see, so from for a outstroke 0 to 6, it is by using simple harmonic motion as the simple harmonic motion method, whereas this will be the different, that is uniform acceleration and retardation. So here in this case, as we have taken, this is 120 degrees outstroke, and divide this into say 6 divisions, and draw vertical lines upwards from each point, and similarly 6 dash to maybe 14, you can say this is also of the same number of divisions, or maybe different divisions also here, because it is a different type of motion, that's why you can take different motion, but it should be different number of divisions may be there, but they should be even number. So that's why 6 to 14 he has taken. And here in this case, in order to complete this profile for outstroke, draw a semicircle with the diameter of equal to the stroke length, and divide this semicircle into same number as done in the outstroke, that means 6 divisions, 1 2 3 4 5 and so on. And after this, draw horizontal lines from each, say 1 is going to meet at 1 dash with the vertical line 1, and 2 horizontal lines, second horizontal line is going to intersect the second vertical line at 2 dash, and similar 3 will meet at 3 dash and 4 dash and 5 dash, and similarly to this 0 1 dash 2 dash 3 dash 4 dash 5 dash 6 dash. If you join all these 6 points, you will get displacement diagram for outstroke. And similarly this uniform acceleration retardation, in this case also same as the previous discussion. Let us see, as we have taken vertical divisions, and from each division draw inclined lines joining, so 14 dash to 14 line, divide the same number of divisions, this middle line, whatever the number of divisions are there in this case, divide this also into same number of divisions, and finally join each point. You will get to 13 dash 14 dash 12 dash 11 dash 10 dash, similarly 9 dash 8 dash 6 dash and 7 dash and 6 dash, etc. So like this you can complete your displacement diagram. Draw the vertical line equal to 30 mm to represent cam lift. Complete the rectangle. Divide the angular displacement during our stroke and return stroke into any equal number of points or divisions. Say 6 points for outstroke and 8 points or 8 divisions for return stroke. Draw vertical lines through each point. Since the follower moves with simple harmonic motion during outstroke, Draw a semicircle with the lift as the diameter and divide into 6 points, divide into 6 number of divisions. And from points 1 to 6 on semicircle, draw horizontal lines intersecting the vertical lines. Draw on horizontal at 11, 21, sorry, 1 dash, 2 dash, 3 dash, up to 6 dash. And join the points 1 dash, 2 dash, 3 dash, up to 6 dash by a smooth curve representing the displacement diagram for outstroke. Since the follower descends with uniform acceleration during return stroke, take the vertical line on the horizontal axis, decide, that means middle vertical line on the horizontal axis, and divide this into 8 equal parts. Join the upper 3 points for vertical line with 6 dash and up to and lower these points up to 14 dash. And obtain the intersecting points 6 dash, 7 dash, 8 dash, and so on up to 14 dash. And join all the points 6 dash, 7 dash, 8 dash, and up to 14 dash with a smooth curve representing the displacement curve for return stroke. So next is, by completing this displacement diagram, let us move on to the cam profile. And profile of the cam when axis of two roller follower passes through the cam axis. Here is the, first of all, draw take center O as the cam axis or cam center, and with the radius equal to the given minimum radius, draw the circle, that is base circle, and by adding radius of the cam, draw the prime circle also, and then mark follower axis, which should be passed through the axis of the cam. And from O to O dash, that is O dash will be the trace point or roller axis. And from this point, mark as assume that the roller cam is moving in clockwise direction and the follower is moving in anti-clockwise direction. By taking O dash O with as reference, mark the angle of ascent 120 degrees and dwell period 30 degrees and 150 degrees return stroke, and then divide whatever the number of parts you have divided on displacement diagram in the outstroke, and also divide the divisions of return stroke into same number as done in the return stroke of the displacement diagram. And from each point, draw the lines for passing through point A and 1 and produce it to some extent, and also similarly second line, third line, fourth line, fifth line, and sixth line, so on. And the 6 dash, 7 dash, 8 dash, 9 dash in the return stroke, that is 10, 11 dash, 12 dash, 13 dash, 14 dash, etc. After extension, mark the distances from the, that means transfer the distances from the displacement diagrams, that is 1 dash, 2 dash to the respective divisions of the base circle and prime circle. After marking points 1, 2, 3, 4, etc., join all these points, you will get your diagram. So let us see once again procedure for cam profile. Draw a circle with radius RC plus R, that is radius of cam plus radius of roller. Draw the vertical position and mark angles theta, outstroke, return stroke, dwell period 1 and dwell period 2 in the counterclockwise direction, assuming the cam is rotating clockwise direction. Divide the angles theta A and theta D into same number of points as in the displacement diagram, that is 6 for outstroke, 8 for return stroke. Draw radial lines passing through the points from center O and extend them outward. On the radial lines produced, mark the distances from displacement diagrams for outstroke as well as return stroke. Obtain the points 1 dash, 2 dash, 3 dash, 14 dash, that means and so on up to 14 dash on the radial lines. Draw a series of arcs for radial or roller for equal to radial equal to RR. Roller radius from the points 1 dash, 2 dash, 3 dash and 14 dash, etc. Draw a smooth curve tangential to all the arcs, which is the required cam profile. Which is the required cam profile, right? So this is a combination of the roller follower. It is combination of both simple harmonic motion as well as uniform acceleration and retardation. And the next is in this lesson is cams and roller follower with uniform acceleration and retardation. In the previous example, we had discussed about both the simple harmonic motion as well as uniform acceleration and retardation also. So that's why here also once again it will be very easy for us to solve this problem. And this specified diagrams cam usually rotates in the previous scene, which is continuous. To recall all the assumptions and everything, usually rotates at uniform speed so that the equal angular displacements take place in equal intervals of time. Follower is required to start from rest at the beginning at each stroke and to come rest again at the end of each stroke. So its velocity must be variable and the period of dwell is a stationary period. In displacement diagram, the follower moves with uniform acceleration and retardation. Divide the lift into equal number of parts. Divide the angular displacement cam for rise and fall of the follower into same number of equal parts as that are on lift. The points A, B, C, D, E, F, G, A, B up to E, and similarly A dash, B dash, C dash, D dash, E dash are obtained. Join these points to obtain smooth curve. That will become the displacement diagram. So here is the displacement diagram as we have explained previously, and this is the angle of rise or outward stroke, and this is the angle of fall, that is return stroke, and between these two will be the dwell period. And similarly, draw vertical lines and also divide this lift also into same number of equal divisions. Draw horizontal lines, and from each O to these divisions intersect. Join all these, you will get points, various points A, B, C, D, E, F, E, F also, and F dash, E dash, etc. up to A dash and O dash. If you join all these points, you will get your displacement diagram. Now let us see one of the problem solving this type of model. A cam with a 30 mm as minimum diameter is rotating clockwise at a uniform speed of 1200 rpm and has to give the following motion to a follower 10 mm in diameter when the follower moves with the uniform acceleration and retardation. And here in this case, type of motion to the follower is also given, and roller follower is also given, and minimum diameter is also given. And outstroke lift also here is the 25 mm, outstroke of 25 mm during 120 degrees of cam rotation, dwell for 30 degrees of cam rotation, and dwell for 60 degrees of cam rotation. And next is return to its initial position during 90 degrees of cam rotation. So del for remaining 90 degrees of cam rotation, draw the cam profile if the axis of the roller follower passes through the axis of the cam. So I think it is very simple for us to draw because as we have discussed previously, minimum diameter of the cam is 30 mm, speed of the cam is 1200 rpm, diameter of the roller is 10 mm, and lift is equal to 10 mm, 25 mm, and outstroke is equal to TO is equal to 120 degrees, and dwell after an outstroke is equal to 60 degrees. Return stroke angle theta r is equal to 90 degrees. Angle of dwell after return stroke is equal to 90 degrees. And here is the displacement diagram. Draw a horizontal line ABCDE with 360 degrees and with suitable scale. And here the scale 10 mm is equal to 30 degrees. And AC is equal to 120 degrees to represent outstroke. And CD is equal to 60 degrees to represent dwell period, first dwell period. And DE is equal to 90 degrees to represent return stroke. And EB equal to 90 degrees for the next dwell period. And here is the displacement diagram for both cases. So 0 to 6 is the outstroke, and this is the dwell period 1, this is the return stroke, and this is the dwell period 2. Same as in the previous explanation, this will be the displacement diagram that is there. That means draw vertical projectors or vertical lines and divide the stroke into same number of parts as divided in the outstroke and return stroke. And A, I, A, J, A, K, A, L, F, L, and F, M, if you will draw lines, they will meet at certain point A and at point B, C, D, E, etc. and F. And then similarly F dash is same procedure it should be followed here also. If you join all these points with a smooth curve, then you will get your displacement diagram. This is all about the displacement diagram. Right? So this is 360 degrees, 120 degrees, 60 degrees return stroke, 90 degrees and remaining 90 degrees. And vertically that is lift of the follower, S is equal to 25 mm. Divide the angular displacement during outstroke and return stroke into equal number of even parts. Draw horizontal lines through 0, 1, 2, 3, 4, 5, 6 and 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash as shown in figure, and divide the vertical lines through these points during the first intervals of the follower is accelerated, and during the second 3 intervals it is retarded. During the middle vertical lines into the same number of equal parts J, K, L, M, N and so on. Join OI, OJ, OK intersecting the vertical lines drawn through 1, 2, 3, 4, etc. at A, B, C, etc. up to, and join all the points O, A, B, C, and so on. With a smooth curve, you will get your. Similarly, for the second half of the outstroke also, FK, FL, FM, intersecting vertical lines, curve O, similarly up to F, O, A, B, C, D, F, in the same displacement curve of the following follower during outstroke. Similarly, displacement curve for the return stroke may be drawn. This curve is shown by F dash, E dash, D dash, C dash, B dash, A dash, O dash. The entire displacement curve is shown as O, A, B, C, D, E, F, F dash, E dash, D dash, C dash, B dash, A dash, O dash. Now the cam profile for this problem. So here in this case, take O as center and the minimum radius as the have to take, and with this draw the base circle, and by adding to this radius of the roller also, then you will get prime circle radius diameter, prime circle also you can draw. And from OA is the center of the roller or trace point, and from OA, starting from this, the assumption of cam is rotating in clockwise direction, we have to draw follower is rotating anti-clockwise direction, so that 120 degrees, 60 degrees, and 90 degrees should mark starting from OA line axis. So then divide the same outstroke and return stroke into same number of parts as done in the, as you have completed in the displacement diagram. And from each point draw the projector, draw the lines producing beyond the point 1 and point 2 and point 3, etc. from each point similarly, and take the distances from 1A and 2B, 3C, 4D, 5E, etc. and mark all the points. Then you will get various points at different points. With that, if you draw a smooth curve, you will get cam profile, and also if you draw from the trace point or center of the roller, you will get a curve that is called pitch curve. So this is all about the displacement diagram for a roller follower. So here you can see all the points, salient points in this. So this is the cam center, this is the base circle, this is the prime circle, and also this is the cam profile, red one, and a curve passing through the centers of the rollers is the pitch curve, and point A is the trace point. So this is all about the cam profile. Draw a base circle O as center with radius equal to minimum radius of the cam, that is 15 mm, and with O as center draw the prime circle with sum of the minimum radius of the cam and radius of the follower, that is 20 mm, and mark angles on the prime circle. Angle AOC 100 degrees which represents the return outstroke, and COD, angle COD 60 degrees for dwell period, angle DOE 90 degrees to represent return stroke. Divide the angles AOC and dy into same number of even parts as displacement and as in displacement. Draw O, from O draw horizontal lines O1, O2, O3, O4, etc. Similarly here also 0. Mark distances 1A, 2B at similarly 6F, and also here also return stroke in the same equal to the corresponding displacements as measured from the displacement curve. Join the points A, B, C, D, E, F, and F dash, E dash, D dash, C dash, D dash, E, A dash, E, and this curve drawn through these points is known as pitch curve. From points A and so on, draw the circles of radius equal to the radius of the roller and join the bottom of these circles with a smooth curve as shown. This is required profile of the cam. So with this, friends, we completed the two things. One is roller follower with simple harmonic motion, roller follower with uniform acceleration and retardation. When the displacement of the curve is determined, the summary of this lesson is displacement of the follower is determined by displacement of the roller center, and profile of the cam is passing through the bottoms of the roller circle. The displacement of the follower is determined by the displacement. So, and same thing. The roller is fitted to the follower in order to reduce the friction and wear. The prime circle OA is equal to the radius of the follower and minimum radius of the cam. Now let us have the quiz in this lesson in cams also. The roller followers are extensively used in automobile engines, paper cutting machines, aircraft engines, and none of the above, which is the right answer. So once again, let us see, the roller followers are extensively used in automobile industry, paper cutting industry, aircraft industry, none of the above, which is the right answer. So here you can see the C should be the right answer. So the roller followers are extensively used in aircraft engines. And next is the following type of cam and follower is used to reduce the friction and wear. Flat faced roller, sorry, this is flat faced follower, roller follower, knife edge follower, and a radial follower, which is the right answer. As we have discussed in this lesson, the roller follower is used to reduce the friction as well as wear. So right, B answer is the right answer. The displacement of the follower is to take place with uniform acceleration and retardation. The displacement curve is parabolic, simple harmonic motion, cycloidal motion, none of the above. Simply we can say A is the right answer, as we have already discussed so many times. And next is when the motion of the follower is along any axis away from the cam center is called away from the cam center. Offset follower. Some assignments here are there. Problem 1, the cam profile to raise a wall with simple harmonic motion through 50 mm in raise a wall. That means outstroke as a through 50 mm, that is lift or stroke of the follower 1/3 of revolution. That means 360, 1 by 3 into 360, that is 120 degrees. Right? Keep it fully raised through 1/12 revolution, that is 30 degrees. That is, keep it fully raised through 1/12 revolution, that means stationary period, that is dwell period. And to lower it with the harmonic motion. In 1/6 revolution, that is 60 degrees. And the diameter of the roller is 20 mm and the minimum radius of the cam shaft is 25 mm. The diameter of the cam is 25 mm. And then the axis of the valve passes through, one rod passes through the axis of the camshaft. Simple problem as we had done. Roller follower, simple harmonic motion. One is the 120 degrees, 30 degrees, and 60 degrees return stroke. And the remaining is the dwell period. And also shaft diameter is given to you. Stroke length is also given to you. So with this previous, same as in the previous simple harmonic motion, you can draw this problem can solve this problem by drawing displacement diagram as well as cam profile. And the second problem, the cam profile. Draw the cam profile to give the following motion to a roller follower. Outstroke 60 degrees, dwell 15 degrees, and the return stroke 60 degrees. Dwell for remaining cam rotation. Stroke length is given to you. Roller diameter is also given to you. Minimum radius, base circle radius is also given to you. And the axis passes through the same. And here is the uniform acceleration and retardation. I think it is also a very simple problem as we have discussed. Thank you, friends. Thank you, one and all.